Okay. Let's start?
Yeah, sure.
Okay, sharding sucks.
That's TPO. Cool, but so do you want me to start to give
Sure.
my arguments? You want to go
just
first?
My opinion is that sharding is a really hard computer science problem. And I think it's solvable, but that's what it is. It's a really hard computer science problem.
But clearly, no sharding is so simple. You had to bring super good minds from Qualcomm to tackle it, right?
I don't think that we would get anywhere. I don't think we would be near the finish line if we tried to build a sharded chain.
but that's the difference, right? You brought talent from Qualcomm because you're building hardcore low-level optimizations. We brought people from MSQL. We shipped sharding before, right? But I have certain arguments towards sharding. I think that for certain use cases, right? If you're talking about payments or DEXs, I think something like Solana works great, right? It's a very homogeneous workload, right? And you can easily process hundreds of thousands of transactions on the GPU concurrently, right? But if you're running an arbitrary smart contracts on a platform, you can only get that much of parallelism, right? So you will be bounded by the whatever number of cores you have on those mainframes running Solana. So for arbitrary code, it seems to me that you do need sharding ultimately. Like at some point, you will reach the capacity of the mainframes if adoption grows faster than this every 2 year, doubling the CPU.
I think you're actually compute is not the problem here. Compute is just so easy to get, right? Like if there's actually enough demand to fill capacity, people will just add more computers. Like hardware is actually really cheap and easy to go get. I think the benefit of sharding is the thing that you can't scale, which is bandwidth, right? We're limited by the bandwidth of the supermajority of the network.
But adding more computers is sharding, no?
No, you have my validator is now a rack of 42-inch rack worth of GPUs, right? I can add more compute easily, right? But I can't run another fiber optic cable to everybody in the network.
So that sort of works, right? So one example is what you gave, where every validator runs a huge mainframe, and that mainframe has so much CPU and so much disk space that it can fit whatever. It can fit all the information the world has. Or there's another school of thought where instead of doing that, they make every validator to run a set of machines, right? But it's internal communication. So adaptive corruption problems don't exist anymore. But that does appear, at least to me, it feels like it hurts decentralization significantly because the requirement for validator now is pretty high. So it's only for a select group of professional enterprise-grade validators who can run them.
My argument against that is that every 2 years, hardware gets cheaper and cheaper, and we're just unlikely to see that much usage in the next 8 years, right? To where it fills up 1 gigabit worth of TPS. That's almost 1 million transactions per second, right? 1 gigabit worth of data, 1 gigabit is available worldwide. You can process 1 gigabit worth of transactions in a 5K machine right now. So the imaginary world that we're thinking about, where we have 42-inch racks of computers, is the world where we have, I don't know, a terabit worth of bandwidth connected to everybody. It's just so far away, right?
But were the networks actually getting that much faster? No. 1 gigabyte has been around for a while, right? But we're not getting much further than 1 gigabit. But the bigger thing is that you can get out of CPU, but you do need to write ultimately, right? You need to write to disk. Disk is not getting any faster over time.
No, SSDs are getting faster. That's definitely true. Both SSDs, anything that's silicon is getting basically twice as fast every 2 years. Not latency, but bandwidth, in terms of how many not sequential, but concurrent operations you can do per second. All that stuff is doubling. Bandwidth doubles, network bandwidth doubles every 4 years, so it grows slowly. 5G standard is 1 gigabit point-to-point, any 2 phones in the world. Mm-hmm. So the amount of fiber that needs to support that across data centers. They're all going to serve traffic to this like 3 billion 1 gigabit devices is insane, right?
Yeah.
So like we're going to live in a super connected world with a ton of available resources. So if you have a network that utilizes all those resources to their full capacity, I think it can deliver the cheapest price for the security of this trust minimizing computer.
And so in your ideal world, how many validators do you think are going to be running Solana who are,
Well, I mean, we designed the protocol like to 20,000 validators. Like that was our simulation. But where are we going to find 20,000 validators? I mean, like, where are you guys going to find validators for, like, I don't know, how many shards do you plan on launching with?
well, let's say 8, right?
Okay, 8, yeah.
But you see the beauty of sharding, right, is that you can run on on the cheapest instance, well, not on the cheapest, but on a very cheap instance, and that's going to be that's going to be enough to process a shard.
So here's my counter argument. I don't think sharding is actually a scaling solution. It's a decentralization solution. And I think people think of it as scaling because it, on the surface, increases the capacity of the entire network. But the price that you pay per transaction is going to be based on the capacity of the single shard. Because what that price is the spam resistance. If you lower it below that, then your full shard gets spammed out of existence, right? And you can't afford that. You can't afford a single shard to be at capacity, because that means all those users, all those applications are dead. They have to now do this long ass migration thing to another shard, right? That's like a huge attack vector. So it increases decentralization. It doesn't actually scale.
But wouldn't you agree that the cost of a single transaction in a shard, it doesn't need to be any higher than the cost of a transaction in a centralized, in a single chain system, right?
No.
Because the cost of spamming will be the same.
If it's running in the same hardware, right? So if it's running on if it's a network that is like optimized like ours, right? That means that we give you 50,000 TPS worth of capacity. Our price for spam is that much lower, right? So that's kind of like I think the main trade-off. It shouldn't be called a scaling solution. It's a decentralization solution, which is fine. Decentralized, to the hilt. I mean, that's an awesome problem to solve.
So that's a good argument. However, I think once you start thinking about transaction fees in the context of blockchains being widely adopted in the wild, one of the requirements for blockchains to actually gain adoption is that the final user of the service does not pay any transaction fee. They use the service for free, and it's the service provider, the smart contract owner, who is paying for it, right? So once we do that, now spamming, even if they cannot spam the protocol, they can spam the owner of the application, right? So you need to have some other way of protecting against spam, right? And it doesn't.
If it's an open network, dude, as soon as the price is below my cost to mess with it, I'm going to mess with it.
Right, but okay, but like let's consider Instagram, right? A cost for me to like sending requests to Instagram is practically zero, right? I can create a DDoS, like a botnet very quickly, and yet Instagram doesn't go down, right? So people seem to have solved the problem of.
But are your validators going to censor transactions that are paying the right amount of fees, but they just like, we don't like these? Because that's what you're talking about, right? Is like
to an extent. So in the bright world of crypto future, which I envision, majority of applications are using this approach with application provider paying for the fees. So so people use the protocol through those gateways of through hosted wallets of the application providers. They paying their gas fees. Application designers, application runners are people who paying for those fees, and they correspondingly through their gateways protecting against DDoS. If you actually need to use network directly, if you don't want to use like a hosted wallet, you need full security. Well, at that point, you actually are in a position to pay a higher transaction fee, right? So if you need full security of the system, you can also pay more for it. Does that make sense?
Sort of, but like you're talking about like basically creating a walled gardens, right, between like your users that interact with. They're not decentralized users anymore, right? They're not self-custodying They're just users of some app. Why doesn't that app just run in Postgres?
So there's a big difference, right? In terms of walled gardens, right? If you don't do that, if you make users pay for the gas fees, it happens that we live in the world, and the world is not going into any different state, where acquiring crypto is extremely complex, right? And so if we require users to pay for transactions, the adoption will never go off limits. Like if you go outside and like grab a random person there, that person will not be buying crypto in any time in the next 5 years, right? So I think making that like this hosted wallet approach is actually making it less of a walled garden, right? And they still gain a lot of benefits from using decentralized network because yes, they do need to trust the hosted wallet provider, right? But first of all, that could be someone like people trust Coinbase, people store crypto in Coinbase. You only do it for low importance transactions, right?
So this is what you guys are building is a decentralized network for not decentralized people, right?
But that is the thing that your majority of your audience, unless you capture the audience which does not fully care about decentralization, people will not go to Facebook if Facebook doesn't have 90% of the population of the world. You need to capture the audience which doesn't care about crypto if you want to capture the crypto audience. As long as crypto audience has their access to full security, full value of the blockchain, people who don't care as much, right? They still gain quite a bit, right? So because if they're using a hosted wallet provided by the application developer, that means that application developer needs to, for some reason to want to mess up with them. So
that application developer, right? They're paying a big pile of fees to access the chain, right? They're paying for the users.
Right.
So in that case, they're the most motivated to switch to a chain that has the lowest fees, right?
Yes, if they
for the same level of security, which is one that is designed with the most hardware, right, per validator. That's how you get to the lowest price.
The question is it equally easy for them to do that? That's one question.
To move over, like for like a company that's spending like X amount, it depends on if they're burning $1 million a year in fees, then it's X amount of engineering hours, right, to do it.
So there's a good argument to that. Argument number one is that what you're saying is true for like huge company, right? If a company built a huge service on the blockchain, and moreover, for a small number of companies, it is most certainly, even if you're a little bit delusional, which you not necessarily are, but even if you're a little bit delusional, Solana is not as scalable, it can definitely host at least several very high-profile applications, right? So for them, it might be reasonable to move. However, one of the beauties of the decentralized applications is that they're composable, right? It's the open state components that are actually going to be making a huge difference in the next years, and hopefully they will be driving Web3. But those open state components.
Sharding introduces an unimaginable complexity to composability.
Right, because
you basically have to build Erlang, right? Like to deal with it.
Except that you can abstract out most of that, right? If you go today to near dev and you're trying to do like a cross-contract call, it's no harder than just creating a future and then acting on it. And TypeScript already abstracts out quite a bit of it from you.
Just that. Yeah.
Unless you need synchronous calls, which is a different story. Asynchronous calls are completely trivial. And today, most of the code in JavaScript that you write already actually relies a lot on asynchronous calls, because historically JavaScript is single-threaded, and you have to rely on asynchronous calls, right? Like if you do jQuery call in your website, right, on your front end,
I know. But
right. But those open state components, their state is going to be coming a lot from smaller players.
Debugging and guaranteeing that all the contracts terminate and execute in safe states that are executing on multiple shards is like a super complex problem.
You don't need to care about it most of the time, right? As long as your logic, like you write your logic, as long as it's relatively straightforward, and most of the time it is. Like how many times you saw people writing ridiculously complex logic on the backend? Like open any Flask application, it's as straightforward as it gets, right? There's going to be no surprises, right?
Yeah, so compile it to SpearV, run it on GPUs.
Right. So the point here is that as long as for the smaller players, it's significantly easier to go and build on something that is extremely straightforward, right? So the open state ecosystem will be coming from the small players. It's not going to be coming from big players. Moreover, the entire promise of Web3 goes against big players. You don't want Facebooks and Googles to exist, right? They're like their position as a monopoly is what hurts the world, what allows them to
But
monetize.
you want like communities equivalent to them to exist that are all using the same protocol, right? Or the same like that are all coalesced around like one thing.
Yeah, you want decentralized communities to exist. Yeah, that. So effectively, you want all the all the biggest services you use today, you want them to be running by the community, right?
Which I think goes against this model where you have services that abstract that away from the user. Like I think ultimately the space succeeds only when we have, 200-300 million self-custody wallets out there. They're all doing something.
But so let's slightly pivot the argument, right? And so let's say that it is actually the case that running a huge mainframe is cheaper
A $5,000 machine
than running a huge distributed cluster. Why is it the case that IBM and Oracle, like they can only acquire those like huge enterprise customers who are ready to pay for their huge mainframes, but majority of people, they use distributed database today. They use MemSQL, they use Cassandra, Mongo.
But like there's like this ridiculous misconception that it's a mainframe. It's literally a gamer box, like a $5,000 machine and a 1 gigabit network. I have 1 gigabit in my house. Like this is like the bare level of what hardware and networks are today, right? In the developed world.
But
so why don't we utilize all of it?
Is it the case? So first of all, is it the case that your 1 gigabit never glitches, right? Because
sure, that's why you have like a few thousand of them, and as long as the glitches are non-correlated.
But also, so let's say
that's the whole point of consensus, right? That whole other thing.
So let's say everything goes well, and within several years, people actually move towards community-driven services, right? Do you think that those gamer boxes, those gamer non-mainframe boxes, can run the entirety of what Google, Facebook, Instagram running today?
Well, the thing that's actually happening on chain, right, is these small, straightforward things where you're just switching ownership, and maybe like you have one giant state machine for price discovery, right? You're not running the Facebook application on chain, right? That's running in the front end. What you're coordinating is like data access, right, and like privacy and like controls, right? Like it's not like this thing that needs to execute in these trust minimizing computers doesn't need to be a Java VM running a big pile of shitty business logic.
But like, why not? Why would I not run, if I can, why would I not run those decentralized applications entirely on chain?
Well, you can really do it even in a sharded system because the resource constraints, right, are huge. So if you are, like, sharding isn't going to help you there, right? Because you're talking about really fat applications unless you have one fat application per shard, basically.
But nothing stops you from sharding applications themselves, right?
Sure.
So like if application is sharded on its own, for as long as the number of shards grows together with the adoption.
And then each application can run its own Tendermint chain, and then I'll talk to each other.
But a single Tendermint chain is not good enough, right? Single Tendermint chain is still limited by what a single machine can give you, right? But if applications themselves are sharded, right,
sure,
then nothing really stops you from running the entirety of the Web3 on chain, which would be, like that's the future I want to live in, right?
Sure.
But you cannot run the entirety of Web3 on mainframes. I mean, you can, but they're going to be extremely expensive. Those are not going to be gamer boxes.
The shard, like the applications you're talking about, they're not going to store data and images on chain. They're not going to store like the front ends on chain, right? All those, right. Nobody's designing that. No one in Ethereum is talking about that. The Web3 people are not like pitching that, right? They're pitching, we store all the heavy stuff in IPFS, and we load everything client side, and we use the chain to coordinate.
Right. But that's also what I'm talking about, right? Nobody talks about storing images on chain, but you want to do all the logic, the entirety of the backend logic you want to do on chain. That's what gives you the knowledge that nobody is trying to take advantage.
Right. So then you have two options, right? You have a sharded chain, which is running low-powered hardware, where the fees have to cover the spam for the single shard, right? Or you have a non-sharded chain that's just running standard hardware, like machines you can buy at Fry's, right? utilizing 1 gigabit, where the full capacity of the network is available to everybody, right? So that I think why would you pick the sharded chain? Like why?
Well, so the reason is that it is unlikely that mainframes, which a large number of entities around the world can afford, can run the entirety of the vision of what Web3 can bring, right? So if we do believe that Web3 will
we agree
come to
that,
existence,
but the Web3 on chain is just doing small amount of logic.
But first of all, that logic is not entirely homogeneous. That's one, right? So if you're running many different applications, most of that will have to be happening on the CPU, right? Unless everybody is running a separate instance of Solana, but that's sharding, right? Exactly, right? So majority of the stuff will have to be happening on the CPU. So you will have to be running all the business logic of all the, like imagine running all the business logic of all the internet on a single, it's like as if Facebook itself did not shard their execution and was running a single huge machine replicated to another single huge machine for processing Facebook, but they don't do that, right?
Yeah. Okay. So there's like I guess the difference is, do you think that we're going to see homogeneous applications that take up the most capacity, or a long tail of non-homogeneous ones that are hard to coalesce?
Right. Yeah. And that's I think the difference here is DeFi. I think mostly going to be largely homogeneous, partially because I think several use cases will be dominating the entire DeFi market. Like a DEX, for DEX, Solana is gorgeous, you know. But if you're talking about Web3 or any other kinds of applications, if we're talking about a whole slew of possible applications, right, that cannot be fully moved to the GPUs.
Sure, but if you have like a game like CryptoKitties that all of a sudden has like a spike in usage, right, that goes viral.
Right.
Because it's going viral, it means all those contract calls are exactly the same, taking the exact same branch, breeding 2 cats, storing this random set of numbers, right?
Yes, but do you envision that in Solana it will be the case that it will always be like one or very few applications that fully dominate the network, and everybody else goes to the CPU? And even if it's the case, is it the case that everybody else will be?
Yeah, I guess we'll see.
Is it going to be? Is CPU going to be enough?
If I could predict that, yeah. I have no clue, right?
Yeah,
like nobody does.
But the beauty of sharding is that it does scale with adoption. And so the particular beauty which I think is going to be relevant short term is that until adoption comes, and it will take time, and it will take a lot of work for me, you, and others who were here today to bring the adoption. Until adoption comes, Near will be very cheap, right? 8 shards on commodity hardware is nothing, while people in Solana already need to run mainframes. Right?
It's a $5,000 box.
It's a $5,000 box.
Well, like if you look at Ethereum, right? You have, 32 ETH, your minimum stake, which is $6,000.
Right. Well, I'm not necessarily saying Ethereum is great.
Right. And not only that, you're running a so-called cheap commodity hardware that will get slashed like with quadratic leaking, right? Like for being unavailable. So you effectively have to run a high availability system anyways.
But again, do you have to build slashing for unavailability? Near doesn't slash for unavailability, right? Sure. So like all of those are contentious points, but they are not necessarily something that is necessary for sharding, right? So sharding is just about whether you do scale out or if you scale up, right? That's the only argument here, really.
But the reality of it is going to be you have 80% of the tokens held by 20 entities, right, at most. So all those 20 entities will have to run a validator in every shard at all times, no matter what you do. So you have like Zilliqa, right? You have the super majority of the stake is running a validator in every shard at all times.
But that's actually not necessarily bad. So the argument here is that if your stake is huge, then you actually can afford to run those nodes, right? But you do want that long tail of participants to be running their small nodes, and their stake is small, but also they don't need to invest in the mainframe, like those clusters, but they are still providing a lot of security. It's not enough to corrupt 2/3. in a system where there are validators and fishermen, a single entity in a shard who's not corrupted can still go and challenge and slash those participants who did collude, right? So for as long as you have that one little, like that one person who made a small
but that
stake.
whole solution is only a solution to a problem that only sharding has. Right? Like you don't need a fisherman and tendermint. Like you have a single chain, single consensus, just
Right, but let's say so let's say there's 1,000 people who run Solana validators, right? So that means that you need 300 people to corrupt, or like you're saying BFT consensus, but it seems like you need more than 1/3, right? Anyway, it's very different than when you have a huge long tail of people, and if adoption grows, right? Today number of full nodes is small, but if adoption grows, you will have a very long tail of people who will be staking, because it's also the randomness is removed, like the lottery is removed. That's a very important property. One of the big problems of proof of work today is that there is a lottery, right? If you buy a GPU and start mining Bitcoin, you will never get your reward. You have to join the pool.
yeah,
increasing centralization. In the proof of stake system, such as the way sharding usually is designed, is that as long as your stake is sufficiently small, is sufficiently large to get into the validator seed, your reward is guaranteed. Right? If you have a lot of shards, if the sharded system takes off, if you have 1,000 shards, each one with like 100 validators, as long as you have 100,000 of the total stake, you're staking, getting your guaranteed reward. So small nodes will be launching.
I mean, but people get lazy and just give their stake to a pool or host it on Coinbase and like, okay, just stake it through this interface, right?
That happens. But remember what was happening when Bitcoin was mineable? Like in my home city, which is like, it's a rural place of Russia where like most people don't even think that you can live there. Everybody was mining Bitcoin because it was cool. Like once you give that back to people, people will be doing that. People will be staking and running nodes on their, on the hardware in their closet. And that creates decentralization.
Yeah, of course. So I think, which is my point, is that sharding is a solution to decentralization, which is very admirable, right? But I don't think it's like a good scaling solution.
Well, it's a play of words. Sharding is a solution to scalability, which has this property that is decentralized, while scaling up is also a solution to scalability, which has a property which it is less decentralized.
It's more expensive to decentralize.
Yes.
But not less decentralized by like constraints of number of validators or participants.
But also, I think one last argument that I personally have against scaling up is that in a system which processes 100,000 transactions per second, there's a certain reliance. Like you really rely on the fact that every 2 years you will be scaling up by some factor, because if you start a new full node, you need to catch up from the genesis. So it's been 10 years. You need to be catching up 100,000 transactions for every second since genesis, right?
Yeah.
So unless your hypothesis is correct and it continues doubling up every couple of years, you get pillaged, because at some point.
My hypothesis is not correct. We should just be buying, non-perishable foods. Like if we stop doubling like how much compute we can do like every 2 years, we're all screwed.
No, engineers will just stop writing twice as slow code every year. They will start optimizing what they do. That's not what will bring the world to the collapse.
If we hit like an information limit, I think that would mean the end of the world in some ways or another. So I can't, like, that's not even an option, right? So silicon, the wafer sizes are gonna keep growing. There'll be some way that they can keep adding more transistors.
Hopefully.
Yeah, hopefully. Cool. Well, this was super fun. We could talk for hours. We could talk for hours.
Yeah.